what does electronics, a ring, a medal, what we use as the gold system, all have in common? It's made out of this material called gold. Gold is resistant to corrosion and malleable. Can you think why? Please refer to reference 1 for this part of the video. On the macroscopic scale, gold has the symbol Au, and it is known for its chemical stability and high redox potential. On the nanoscale, the unusual electronic configuration of Xe, 4F14, 5D10, 6S1, amongst other effects, causes a change from a metallic to a semiconducting character of very small particles. It also has excellent resilience to corrosion, malleability, and high density. The lack of reactivity makes it a versatile product and in high demand. Gold crystallises in the face-centred cubic structure, hence its malleability, and is therefore often used in alloys. As alone, it is very soft. Gold is found in every continent apart from Antarctica, with China producing 10% of it for the world, followed by Russia, Australia, and Canada. Gold cannot be created on Earth and is rooted in cataclysmic cosmic events. Gold typically occurs in its pure form rather than in a compound, with its distribution around the world affected by geological settings and processes. Gold is challenging to find and complex. The likelihood of discovery is less than 0.1%. There are 2 types of mining practices: surface mining and underground mining. Surface mining may include quarries, open pits, strip contour mines. Surface mining can be dangerous in unregulated areas due to the chance of slip, trip and falls with large machinery. It also requires large areas to move extensive material. Underground mining involves working underground with shafts and complex tunnels. Small-scale mining usually uses simple pickaxes, while large-scale mining uses automatic and great large machinery. Gold can be refined in a series of ways. You can put it into a furnace and separate it from the other materials based on their heat capacity. And you can also use cyanide or mercury, which we know is dangerous and we will mention later, for chemical processes. You can use electrolytic refining and use an electronic current and pass it through the impure gold. Left, you can see the underground mining, and you can really appreciate the size of the tunnels and the machinery used. On the right, you can see the surface mining, which looks much more like the mining we're used to in the UK with abandoned quarries. However, this, like I said, uses a lot of land to remove the material and put it on the side, destroying ecosystems. Please use reference 5 for this next segment. On the left, you can see some illegal mining, and on the right, you can see some large-scale mining that creates dust. So what are these concepts? Small-scale mining is mining that is undertaken only by a few individuals, and they're often the poorest people in society working illegally. It is very manual due to the lack of resource and puts people in safety risks. It also puts the environment at risk. They do not secure a permit which investigates the environmental impact and mitigation. Large-scale mining is done by large organisations, and they often are done legally and have permits, which have been decided by the government. However, they can actually take land off the indigenous people, and they also require a lot of land for their processes, causing a lot of deforestation and the destroying of ecosystems. Environmental impacts of mining. Air pollution. Small-scale miners burn toxic materials like mercury in unsafe, poorly vented areas. Mining can generate dust and release of harmful gases. Processing can lead to arsenic pollution, and that can filter into the water and the air. Vegetation and forest degradation. Mining often destroys land and forests with abandoned pits, leading to barren mosquito breeding sites and erosion. Surface water. Mining discharges mercury and cyanide and soils into rivers and streams. Contaminated water affects fish populations. Improper disposal of chemicals can get into the water system. This endangers wildlife and communities. Soil and food crop pollution. Mining contaminates soil, which mixes with toxic substances and can be spread onto agriculture areas, causing crops to absorb them and get in the food chain. In Bolivia, the SRL granted 3,000 hectares of mining, which affected the land of the indigenous people. Human health. Studies show that miners and local inhabitants in Ghana are exposed to dangerously high levels of arsenic and mercury. Illegal miners also generate dust without significant dust controls, leading to early onset of lung disease. Arsenic also pollutes the food chain and when eaten causes cancer. Skin contact of chemicals can also cause an issue. A health station in Bolivia saw its patients who live close to the areas of mining facilities with stomach ache and diarrhea. Gold and human rights. Personal insecurity. Violent encounters can occur between small miners and government to stop illegal mining. Community uprisings for poor treatment of miners. Clashes between local communities and the large-scale mines over land access and lack of employment. There's violence from robbers and work pressure and job instability due to how where the gold is. Forced labour and trafficking is present amongst gold mines. Child labour and school dropouts are common in gold mining areas. In Ghana specifically, there can be conflict between Chinese miners who get paid more than the Ghanaians. Much of the mining on the small scale is due to the lack of opportunities, with women more likely to face injuries due to the tasks they perform being more dangerous to men. International mining companies and governments absurd residents for land exploitation. Much of the government and the tribes taking bribes. Lots of the indigenous people have no rights over this. In Peru, many conflicts between the miners and the indigenous people are due to the overexploitation of gold or payments to loyalties, and the government is weak and they cannot help. In Bolivia, there has been many forced displacement and many organised crime, including trafficking. Is there a positive? Well, in more developing countries such as Australia, mining can be successful and improve the lives such as the Aboriginals. When structure is maintained, it has community impact and is providing jobs and female entrepreneurship. Why are standards so poor? Well, the lack of monitoring, audits and guidance, the lack of legislation and the fact only a few countries require or even follow it. The supply chain is very complicated due to illegal miners often trading through lots of different people. That provides a lack of audit trails, and it's hard to get to the root source of where the gold actually came from and who even mined it. We're not protecting the environment enough. There is so much more we need to do. This image shows how gold gets from the miners to the people who go on to sell it. It's very complicated. So how can environmental and human rights be improved? Well, use recycled gold. It avoids the human and environmental risks. Recycled gold already accounts for a third of the total gold supply, with 10% coming from industries. Recycled gold creates a circular economy. Use companies that use fair trade and buy from companies who source sustainably, such as Tiffany & Co. Lab-grown gold is in the pipeline, however it is very expensive and new, so perhaps the other materials can be used, such as platinum or silver, but they still require sustainable sourcing. Synthetic gold surfaces do exist, such as PVD coatings and sustainable decorative alternatives to gold plating, but they may not be as strong. Use gold companies that use guidelines, such as responsible mining principles. Overall, try to use fair trade gold, or try to use recycled gold, and ask yourself, do you need it? Is there another alternative? Recycling gold is actually easy, and we recycle 1,200 to 1,400 tonnes a year. It is easy to do due to its high chemical stability value and the ease of separation without loss of quality. It is melted down and unwanted materials are manually separated, or by dissolving in a mixture of hydrochloric and nitric acid. You filter off the impurities or immerse it into electro solutions. From that, you can then refine it, remold it, and reuse it. 25.8% of gold is recycled. Please pause the video to familiarise yourself with the references.